Hi everyone, welcome to our video on finding the intervals of increase and decrease where we have this exponential function involved. Okay, so it's still this step, find the critical numbers, find the intervals where it's decreasing and increasing. It's still these same four steps, so no matter what they give you, it's always just broken down the same way. All right, so step one, I want to get my derivative. So f prime of x is, okay, so this looks like it's a product. I mean, it is a product, e to the x squared times x squared minus 6. So I'm going to use my u and v, and I'm just going to write this out as u prime v plus uv prime. And then now let's start to plug those in. All right, so the derivative of u. So it's an exponential function. The way I do those is I copy and paste the same thing, e to the x squared. So the derivative of e to the x squared is e to the x squared times the derivative of the power. So the derivative of the power is 2x. So that's the u prime. Then v is just x squared minus 6. And then we have plus u, which is the e to the x squared. And then the v prime is 2x. So the derivative of x squared is 2x. All right, and then look at this. We want to factor. We want to factor the best we can. And then notice, well, before we do anything, you might see it. Here it is. E to the x squared is in common. We could factor that out. So it is multiplying everything in each term. So we could factor it. You could distribute and then do this. But if you catch it now, this is a little easier. Notice also 2x in this case. So we're real lucky here. That is also in common. So we could take that out as well. Which means, let's get one more parenthesis, which means we're left with x squared minus 6 plus, and then we took everything out of this, but we wouldn't write 0. Remember, if it's really just dividing these out, would be 1. And then quick check, remember these, you could see if they, I'm just bolding it a little more. These, if you distribute back in, well this, and let's put that in parentheses still, sorry. This times x squared minus 6 is this whole big first term. And then this times positive 1 is the whole second term. So it is matching. And then we want to simplify one last thing here in the parentheses. Notice negative 6 plus 1 would add. So we have f prime of x is e to the x squared times 2x times x squared minus 6 plus 1 is minus 5. Okay, and you could reorder it if you want. So like this 2x, you can move to the front, but I'm just going to cloud this as is. So this is the fully factored set, or fully factored derivative. Now the x squared minus 5 is a little weird. It's a quadratic, so you might say we could try to factor it further, but I'm going to leave it as is. All right, so we have this setup, and then now our step 2 is to set this whole thing equal to 0. So 0 equals e to the x squared times 2x times x squared minus 5. Remember, if it was a fraction, so our case from before is to set the numerator and denominator equal to 0. Here we didn't have a fraction though, so that means just set the whole thing equal to 0 and proceed. Well, once you have one side set equal to 0, each of these factors can be set equal to 0. So we'll set all of them equal to 0. And then we'll start to solve all of them. All right, this first one has a problem with it, e to the x squared. Now, if you try to use your ln, so usually to solve for an e expression, we get ln involved. But ln of 0 is undefined. Ln of 0 is undefined. So that means we're stuck, which is actually kind of good. This one has no solution. So if this ln is undefined, ln of 0 is undefined, this is no solution. Okay, so this first one has no solution, which is good. It just means move on. Okay, so if you get something weird, that's okay. So if you get an undefined, I mean, I can't go any further. So usually we use ln to bring the power down. So this x squared usually would go down to the front at this point. But again, because ln of 0 is undefined, we have nothing left to solve for. So x squared equals undefined doesn't make any sense. All right, so we have no solution. Moving on to this one, well, this one's really easy. Just divide by 2, and you got it. X would be 0. So that's one of the critical numbers. Let's go ahead and box it. And then this one here, well, I would add the 5 over. So we're going to add 5 to both sides, and we'll get x squared equals 5. And then we could square root both sides. If you square root both sides, remember to do plus minus. So let me make that a little better. To do plus minus on the numerical portion. And that way you're going to get two answers. You get x is the positive radical 5, and you get x is the negative radical 5. Okay, so there's all of our answers. So we have three critical numbers. So these three are the critical numbers, all three of them. All right, and then now that we have our critical numbers, well, it's going to be number line time. Okay, so with the number line, plenty of space. We want to put these in order, so let's put negative radical 5. It's the only negative one, so we'll put that on the left. Then 0 would be right there, and then radical 5 is about there, we'll say. And these are our x values. And then we want to find what the sign will be on our f prime, which will tell us what's happening with our f with increasing or decreasing. So to figure out these f primes, I'm just going to plug in any number. You can start wherever you want on the number line. Let's go ahead. I'm going to start on the far right. So square root of 5 is, you could use a calculator and see what that is as a decimal, but I know it's about 2 because the square root of 4 is about 2. So I want to do something bigger than the square root of 5. And well, I'm just going to choose 10. So let's choose 10. The next square root that we could do without a calculator is the square root of 9, which is 3. Since square root of 9 is bigger than square root of 5, again, I know 10 is a safe value to choose. Okay, and all I want to do now is use it in our clouded derivative, which I just put a big star by. And when we plug it in, we'll have f prime of 10 is equal to e to the 10 squared. So I'm going to plug it in as we go. So I'm changing those x's. So e to the 10 squared, so that would be e to the 100, times 2 times 10 would be 20, times 10 squared is 100, minus 5 is 95. Again, I'm doing it all in one big step. If you need to, break it down in some scratch paper or get a calculator and use it there. But I'm going to just plug it all in one big one. And I see, well, e to the 100 is positive, times 20 is also positive, times 95 is also positive. So all of that times together would be positive. So this stays, oops, and you could write the word positive. I would usually use the symbol, though, at this point, a little positive. Okay, and that's another reason why this has no solution. Let's add a rule right underneath it. Rule. E to a power is always greater than 0. Okay, it doesn't matter what the power is. So if it's negative, remember all that would do is flip it. So a negative power only flips things around. So that means no matter what, it's a positive value. Okay, so that's again why this doesn't work, because to equal 0 would contradict this. So our rule is e to any power is always greater than 0. So that's why I don't need a calculator for e to the 100. I already know it's positive, and then times a positive times a positive, everything's positive. All right, and then in our next portion here, I want to use something in between 0 and the square root of 5. Again, the square root of 5 is just going to be a little bit bigger than 2 because the square root of 4 is a little smaller than the square root of 5, and the square root of 4 is 2. So I'm going to use 1. Let's use x equals 1 here. All right, and to do this, let me go ahead and make sure we'll have enough space. I'm going to drop it down here. So f prime of 1, again, I'm back to my starred clouded equation, and I'm plugging 1 in for all the x's. Well, e to the 1 squared is e to the first. And then we have times it by 2. Times 1 is still 2. And then 1 squared is 1, minus 5 would be negative 4. Okay, so I have a positive value, times a negative value. Well, 2 positives times a negative would be negative. Again, we could double check with a calculator to see the sign for sure, but I'm just using the rules for what happens when we multiply positives and negatives to get this answer more quickly. Okay, so I know this is negative, so I'll put my little negative symbol there. And then now I want to do something in between these. Well, x equals -1 would be in between. Okay, because this is about the negative root 5 is about -2. So again, I know this is going to be smaller or going to be bigger. It's in this interval and it works. Okay, so now let's plug that in. So f prime of -1 goes in here. -1 squared is still positive, so this is e to the 1. 2 times -1 would be -2. And then -1 squared is 1, minus 5 is -4. Okay, I have a positive and a negative times a negative. 2 negatives multiply to give a positive times a positive is still positive. So this is positive. Okay, and then one last time, we've got anything less than the square root of -5. Well, I'm going to do x equals -10. That's smaller than it. And then let's put our work, so this works a little kind of zigzaggy. Let's put it right here. Okay, so we have f prime of -10. -10 squared is again positive 100, so it's e to the 100. 2 times -10 would be -20. And then -10 squared is positive 100, minus 5 is 95. So I have a positive, negative is negative, times another positive gives me negative. So 1 negative and 2 positives is negative. So this is the negative symbol. And then now we have it. So where f prime is negative is where f decreases. Where f prime is positive is where f increases. There we are. Okay, and so we have all of our answers. So this was our step 4, doing all this in the number line. And then now let's make sure we write it correctly. All right, so where it increases, I'm going to do increases first. Negative square root of 5, comma 0. And then square root of 5, infinity. And then our decreasing interval looks like it's from negative infinity to negative root 5. And then from 0 to positive root 5. All right. Now, this one, let's also go ahead and check this one. Okay, and one thing to notice too, notice it does alternate often. So decrease, increase, decrease, increase, but not always. So this one it didn't. Okay, so be careful. That's why you should still always check all the intervals to make sure. All right, and what we've got, let's go ahead and get our calculator, graphing calculator. So here it is, and let me erase these. All right, and then I'm just going to plug in that, let's use those parentheses. So the e to the x squared, one more, there we are, like that. And then parentheses x squared minus 6. Like that. All right, and well, this one's a little tougher to see. Look at that, it's weird looking, huh? Okay, so this is where the graphing calculator is a little tougher. You might want to change some of the settings. So like the amount of stepping that we do. So let's just go from like -8 to +8. That might help. And then it looks like our y, let's go a little further down. Let's see, 100? 1,000? Okay, so that works. Okay, so I'm just making it to where I can see it, and then let me scroll back up. Okay, so that looks like it's good. Okay, so sometimes you might need to change. So this is called the window of the graph, and it's just telling you your smallest x value, your biggest x value, your smallest y, your biggest y. And then I just moved it, so it's changed those slightly, but we can still now see everything. And then notice with this graph, well, it's going downward. It's going downward until we get to this point that they marked as this. Well, is negative 2.236 the square root of the negative square root of 5? Well, let's check real quick. Okay, so I've got 2.2. Yep. Okay, so it matches. Okay, so that's what I mean, where we need to sometimes get an actual value that is not a decimal. Sometimes they want that, which is called an exact value, the square root of 5. And that's where just graphing it by itself might be trouble to find, because then you might have to guess. It might be just some other weird fraction. Who knows? Okay, but that's looking good, right? So we have that. Is that matching? Negative infinity to the negative. Yep. And then afterwards it increases. It increased to 0. Yep, that's where it's drawn upward from left to right. And then afterwards it goes downward. That's the 0 to the square root of 5. Yep, that's that. Good. And then afterwards it increases. Okay, so everything matches as we found it to be with our handwork using calculus. All right, so that's that. Use a calculator to help, though, whenever you can. But that's it. If you do have questions, let me know. Otherwise, thank you for watching, and I will see you again next time.